Okay, welcome everyone. My name is Robert Hodges. I work for Altinity. We're sponsoring today's OSACon conference. It's my pleasure to introduce Tanvi Pal and Stephen Jakubowicz. They are both from COTA. Let me tell you a little bit about their backgrounds. Tanvi is a software engineer with wide experience in open source front-end technologies, Angular, Node, Cube.js. She has also worked with a number of back-end databases. She's has a experience in financial services, shipping, and healthcare, and today's talk is in that last field. Stephen is a product manager and is for COTA, and he leads many of the teams of engineers to design products to deliver healthcare solutions. So with that, I'm going to turn it over to Stephen and Tanvi. Take it away.
Hey, thank you so much, Robert, and thank you to everyone who's joining in for this session today. So just a little bit more about me. I've been at COTA for nearly 5 years. As anyone who's been part of a startup before knows, there have been about 5 iterations of the company in that time since I've joined. So it's definitely been a ride and just an incredible place to learn, grow, and contribute. So you'll get to meet Tanvi in a little bit when she takes over, but I just wanted to say how excited we are to talk to you all today and very honored to be in the company of such a bright group of people who are taking open source software to the next level by developing impactful use cases in thoughtful and creative ways that really stretch the limits of how these softwares are being used every day. So just think that's absolutely awesome. And last but not least, wanted to give a shout out to Altinity for hosting and having us here today. Thank you very much. So I'll go through the agenda right now. So first, I'll be talking a little bit about COTA, where we're from and what we do. Next, I'll talk about how our product fits into the COTA ecosystem. Finally, I'll give a brief overview of the product, including what functionalities we built to date and walking through how our clients are using it. Post this, I'll hand it over to Tanvi, who will get into the really interesting stuff. She'll give an overview of our tech stack and then provide some examples and talk through how we're leveraging Angular, Plotly, and last but certainly not least, we'll cover Cube.js using a variety of examples. All right, let's jump in. So who is COTA? COTA is a health tech company founded in 2011 that's focused on curating and delivering the highest quality hematology oncology data that's available in the market. Operationally, what we do, as shown by the images here and starting on the top left, is we work with providers to access their EHR data in a HIPAA compliant manner. And this includes fields that are captured as structured in addition to unstructured data, such as doctor's visit notes. After using what structured data is available from a network's EHR, we then use our team of highly trained manual abstractors to fill in the gaps using whatever notes and data sources are available to get the full and complete picture. Post that, we clean and standardize the data and we put it through a rigorous QA process. And at the end of the QA process, we have an output of regulatory grade RWE, real world evidence, which is longitudinal over a patient's journey. And I emphasize the word regulatory because COTA has partnered with the FDA in the past to use our data. Just a confidence booster that the market does see the data as very, very high quality. So I want to talk about just really quickly the two sides of the business. The data, after it's curated, cleaned, and made into an output, is then used for the two sides of our business, which are research and quality care improvement. RWA is the product that delivers that data back to providers. So finally, on to RWA. What does it actually do? So RWA stands for Real World Analytics, which is powered by RWE, which is real world evidence or real data on patients. RWA is a data visualization and analytics tool that uses the data from health systems that we were just talking about that we've curated in order to better ask and answer questions about an institution's population. So one of the most popular uses for RWA are for understanding testing rates for an institution. Certain cancer patients have specific molecular indications, which can be very important in order to both understand the most likely outcome for that patient and prepare that patient better, but also to provide the optimal treatment for that patient. So there are novel drugs being produced for many of these molecular indications that work incredibly well if the patient has that specific gene present, but would not be offered as a treatment option if the patient tested negative for that gene, or if the patient wasn't tested at all. So guidelines go out every year that state which patients should get tested. And while it would be amazing to believe that these guidelines are adhered to 100% of the time, as soon as they come out, this is unfortunately often far from the case. There are a lot of reasons why the newest guidelines for testing a population might not be followed, and they range from everything from forgetfulness to not having the time to read and understand the most recent guidelines, to issues with payment authorization and reimbursement, and the list goes on. So what RWA does is it allows an institution to ask these really important questions and then allow the institutions to understand their true testing rate and slice and dice further to learn the why and the who of those patients that are not getting tested and should be, in an effort to alter operations within their facilities, correct the oversight, and then get the right treatments to the right patients ultimately. Conversely, when an institution uses RWA and finds that they are 100% following the most recent guidelines and providing the best treatments available for all patients, this is something that they're going to want to talk about with payers and patients alike. This is a really good thing. So that's just one of the use cases, just to give you an idea of what RWA does. So I hope you have a slightly better idea of who COTA is and what problems our product is working to solve. So now I'm going to turn it over to Tanvi to go into the awesome technologies that we work with that make this all possible. Over to you, Tanvi.
Thank you, Stephen. Good morning, everyone. My name is Tanvi, and I'm a senior software engineer at COTA. And I'll continue the discussion further in a technical sense. Just to continue with the background of RWA, our audience is highly specialized in clinical world, but are not that tech savvy. So that they're not typical analyst users. So we have to make sure that the things we make for them are really, really simple. No analytics solution out of the box has been adequate, has adequate features for our customers' need to date. That's the reason we have collection of different tools to best show the insights to the clinical stakeholders, which can read the data without in the simplest form, as I had mentioned. So how has open source helped us? When we were in the very seed phase of the product, we used proprietary products because we are so used to it, and we started like seeing how our product is evolving. Is it going in the right direction or not, and is it like resulting the use case? And also once that was all done, for development purposes or for the actual application, we moved to open source. Now, why we moved to open source? We have mentioned here the advantages. Definitely cost, faster development and customizations. Because it's open source, it has ability to evolve into something larger than size, and community support is, I would say, the biggest USP of any open source application. There is no vendor lock-ins, so update, replace, whatever if it doesn't support your cause. Initially, when we started working on the app, we used to design very simple like charts, visualizations, where it was simple pie chart, bar chart, donut. But then we realized we need to do some complex data structures because of the requirements which comes into different clinical, I would say, requirements or recommendations. So we went into a different charting library, Plotly, which we would show examples for, where the complex data structure, complex objects used to be is shown. And definitely last but not the least, it's better support and quicker iterations, because if you have any bugs or any issues, you can just check with your community. You can get workarounds for it. And if the bugs or requirements become big enough, you can have it maybe in the next upcoming releases. So this is one thing which I think everybody would agree to that. Next thing, we would like go through the RWA Tech Stack. As you can see on the front end, we predominantly use Angular as a framework, and we use Plotly for visualization purposes. We use Cube.js client on the front end. The backend comprises of Node.js Express running with Cube.js server. And in both the sides, backend and the front end, we use TypeScript and libraries like Movement, utility libraries like Movement and Lodash. So we use predominantly Plotly for visual, and Cube.js acts as a bridge between our database layer, our databases, and our actual server, I would say the app service. So yeah, so we would like to give examples on how we have used these two and helped evolve the application. Yeah, so here I would like to give example of how Angular Plotly has helped us create a chart hierarchy to show a complex data structure. Now here you see the title of the chart is MSI MMR status. This is tells you a population of how proteins in colorectal cancer has been like segmented. Now this is called as a subplots because it consists of multiple plots together. Now the clinical utility is easily seen in the roll-up. So the left-hand side, the donut you see is the roll-up, and all the vertical bar charts, the stacked vertical bar charts are nothing but individual proteins for each, like for individual proteins and the different, I would say, the values. So the for research purposes, actually the individual proteins makes more sense, and the interplay between the donut chart and the vertical bar chart helps in research and physicians for both. Now this could have been an easily 6 or 7 different charts together, but that doesn't provide a good US the UX interface, nor like a good I would say usage, because you don't see the interplay in the right sense where one chart would be up, down, so you don't see what updates where. And trust me, like it took us a good round of iterations to come to this solution where we could have everything together. So Plotly actually had a lot of has a lot of power, which we used in this case to generate this kind of structure, which was very complex from the data perspective. So yeah, this is one example for visualization which we would like to wanted to talk about. Next is Cube.js. Now this is something which we are very like I would say are collaborating to a lot of extent, because we actually came in same time when we were seeding. Even Cube.js was also putting their foot in the open source world. So I can say like we have actually grown up together. We have demonstrated a lot of like back and forth communication, contributions are like evolved over the time from both of our ends. So I think this is a place where we would like to open source community has been like formed between both of us. One of the biggest example is the pre-aggregations. Now, what is pre-aggregations? We all know it's like the pre-aggregated computations to save a result, which is going to be used for a lot much like for a longer like repetitive usage of queries. Now, if your data layer doesn't support pre-eggs or pre-computation, then in that case you write something like what you see on the left side in a data layer, in a service layer, where you massage that particular object to get the result set. Now in this case we take an example of BMI. BMI is nothing but weight by height square multiplied by 703. Now in this case we are bucketing each each patient into a bucket of a BMI, so that when institution wants to view, like, okay, show me how many of my patients are within this BMI bucket, then it's easy for them. But in this case, if you do not have pre-aggregations and your data base has no like calculated column, you will do the calculation on every service call. So that is a performance head, and like it's not at all manageable. Now, on the right side, if your data layer supports pre-aggregation, in this case, like Cube.js does support pre-aggregations. So all we need to do is add your update your SQL to set this particular bucket. And once that is done, you just run the surveys, and the app table which gets created, or the pre-aggregated table which gets created, will have the column for the BMI calculations. All you have to do is just read from that column and you are done. So it's easy to like maintain, it's faster because you don't need to do the calculation on every service. So this is just a simple example, but we have used it for multiple different clinical, I would say, computation. The biggest, I would say, the advantage of pre-aggregations is the data is not held in the database per se, it's in the application data. So you can do updates, you can do like direct, like I would say, if you just want, for example, for an application, you just need to change, add a label. For example, if I say I want the label to be called as less than 18.5 in the brackets, say BMI, or let add some instead of like the greater than less than sign, you need to have in words. Now I can just go and update that. I don't need to go to the data team and then say, okay, give me these updates, put it in the system, and then give it to me. So this has become very easy, because Cube gives us the, I would say, opportunity and the flexibility to update it directly and get everything. Now you can also ask, like, what happens when something gets changed? How does, do I need to restart my services? How does that run? Cube.js, I think, has not I think, like Cube.js has the ability to actually refresh the data. So you can set some pointers, say, okay, keep reading the modify date time of the table for less than 2 minutes or less than 10 minutes, or check in every 24 hours. You can set a timer for it to read itself, like whether it got updated or not, and it will refresh itself. So it's like you don't need to worry about anything if your database, your services are all running fine. And so this is like an example of pre-aggregation we wanted to talk about. The next is the Boolean logic. Now, this is something when we started working with Cube, Cube only supported and. So we went to them and said, we have something upcoming where we would like to have a use case where we supported or. You can see the example here, like in normal like guidelines, recommendations for any breast cancer institute is that for metastatic breast cancer patient, you should have minimum 1 BRCA test. It's a very specific marker test. So how do you do it? So normal SQL query, as you can see here, even in our application, we have is give me when the disease is breast and you are in a metastatic mode is true, then your test name either is BRCA1 or your test name is BRCA2. So there are 2 types of BRCA tests. Now in this case, earlier they did not have the support, but we went to them, we did talk to them about how we want to get it done and what are our different use cases. And as I said, like, why do we use open source? Because if such requirements become a universal problem, we typically solve it together. So this is what happened here. We solved it together. This gave us it in the upcoming versions. We had the whole roadmap planned together. And when they released it, we took it out and we got the results. So you can see from the left side, for this example, I see that total records of 640 patients have undergone BRCA test, minimum 1 BRCA test. And if you see in my funnel visualization to the right side, out of the 10,000 plus breast cancer patients, out of which 1,400 approximately were metastatic, 634 out of 640 had BRCA and 633 out of 640 had BRCA2. So it shows that your institution was going in the right direction. Definitely 7 or 6 here and there, but majority you are going in the right direction. So this is one example of Boolean logic, is what we call as the Boolean logic, because it's and or. You can have different kind of rule sets, rules. You can have, let's say, or between multiple different, I would say, tests, or in between so many other. So we have a lot of options coming in here and different kind of rules and rule sets here. Last but not the least, this is an example where I would say the extension, or I would say collaborative approach came into picture. Now, whatever you see on the left side is the static schema. This is nothing but one-to-one mapping of what you see in the data table database is what you see or what you can query to. So here you can see in the left side, my static schema says, so the schema is nothing but the map file for your cube, for your database, a data table in the database. So if, for example, if your SQL says select star from test, you can have an ID column, which is the primary key. You can have a test, because there's a test, you can have test A, B, C. So you have the columns names test A, B, and C, or whatever that follows. Now, because we work into clinical world, number of tests undergone by any patient can be enormous, can be like thousands and thousands of tests. So something which is on the left side might not work for us. I mean, like, definitely will not work for us, because you can't keep on updating the schema every day, every time, or every new test gets added into the system. So what do we do? So instead of going with that structure, we went to something called as dynamic schema, which is called as async generation of schema or async module. So if you see at line number 2, where we put in the attribute keys, that means you can put in, either you put it hard coded as we did it here, for example, or you can read it from a table which tells you the list of the tests which are getting injected in the system. And all you do is read from the keys and generate the schema, as you see here in this line, where you create the dimensions name. A dimension name is nothing but the column name, and set what it should read, and then you create the schema dynamically. So here, now if tomorrow we have test till Z, I don't need to write any code. I can update it in the attribute keys table, read it from that table when the schema is generated, like when the services are running. And once it gets generated, I can just use it by saying select star from test C, which will work either in static schema or also in dynamic schema. So this becomes like very portable in case of when you have a lot number of tests coming up. So this was an example where, like, we had actually had few issues when we were working on that, because we had a lot of data coming in, which we resolved by talking to each other and got it like fixed it up. So yeah, this was an example of async generation of cube schema. So yeah, this is what we had to demonstrate to you guys of how we are leveraging open source from and Cube.js and Plotly visualization. If you have any questions, we are open for it.
Great. Thank you so much, Tanvi and Stephen. Yeah, so if you have questions, you can go ahead and queue them up in the question and answer box. Here's a great question, Tanvi and Stephen, either one of you can jump in on it. How did you vet and determine which components would become part of your tech stack before starting development?
Yeah, I think it's a great question. We all go through this particular question every time we start working on that, whether this is the right thing to go or not. I think for me personally and for the team, what we usually do is we vet it out, we talk about it, and we actually just do whiteboarding and see whether a particular small POCs, if we call it like proof of concepts, whether particular, for example, charting library, Plotly is not the first one we tried. We tried number of other charting libraries to see whether we can get what we really want, because when we are working with data, which is like a lot of clinical, which is sometimes can be very flat, or sometimes can be a complex, like a JSON object, which is having like hierarchy inside it, it becomes the transformation of data also is important when it comes to like visualization. So we have to make sure that whatever we choose, we do a bit of POC on that. And if it check marks are top 5 or top 6 particular list, then we definitely take it up. And over time, if it still goes through, all good. And if it doesn't, then we'll go back to that circle. So I think this is what we follow.
Great, thank you very much. I have a follow-up question. Oh, here we go. So another one, how do you minimize dependencies on your tech stack in your product? Was that a consideration for you?
Yeah, I mean, like the minimal dependencies, yes, we try to do check on that we don't add a lot of like dependencies inside the app, so that there is not like, we don't open door for a lot of vulnerabilities as well. I think basically we try to see if we can get it done by get it done within our own tech stack, within our own whatever we have today, so that we don't need to go we don't need to see in the open source world again. And if, for example, we need to go out, then we see, can we get it replaced? Because if the same thing can be done by the other thing, why do you need to do it like together? So I think we do take this into consideration whenever we are working on do we need to have a new new dependency, whether it can get whether any other dependency can be replaced for that, and what are the, I would say, how are the community also, because that also helps to understand how is it going to grow and all that. So we see everything.
Great. I have a follow-on question. This one just popped up right as I was about to ask it. So you made an interesting point that the Cube.js, it kind of gives you this layer between you and the database. And it sounds like you have a DBA team that's on the other side and kind of owns the database. Can you talk a little bit about how Cube.js, maybe dig a little bit more deeply into how Cube.js enabled you to work with the DBA team? Because I think that's a really interesting point about this technology.
Yeah, I think Cube.js, I think see, I'm a senior software engineer who predominantly works into the applications part of it. So I am not a DBA, right? So if I have to do some calculations, I have to say, okay, call to my team, give them a SOS call, okay, I need some help to get this done, data to read it in the right sense. I cannot, for example, it's too difficult for formatting. It's adding a lot of headache on the service side, as I showed in the example for pre-aggregation. That was a simple example, but something like this can happen. So so the DBA team predominantly works on the clinical data. So for COTA, our provider or RWA is one aspect of the company. We have different other things that people work on. And since we're a startup, we have many things we have work on. So if I have to do some simple things like BMI or updating the labels, I don't need to go and call the data team and then say, okay, how do I do it? Cube gives me that, I would say, push that I can do it on my own, and definitely get it clarified from the team that from my DBA team that yes, it's all going to be it's working fine. So that I feel is that empowering is what I get from using Cube.js. That is one thing, definitely. Second is it's a one-to-one mapping from your data table and your application. So I don't need to write my SQL queries. For example, if I do select start from test, if the column name changes, if there is some issue with the type of the column, I don't need to worry about that because Cube schema takes into consideration. So my development, and so I don't need to retread the wheel, I would say, and I can just concentrate on developing the application rather than developing something which like a bridge as Cube.js is already doing. So I can concentrate on what I need to resolve the solution for, which is the clinical product.
Thank you. Please go ahead.
No, and I was just going to add from my perception that the DBA team generally really appreciates when we use Cube.js, because Tanvi mentioned that it allows us to do some simple things for sure, but it also allows us to do some really complex work, which at that point is taking, time that they would have spent and using Cube.js to do that. So it's giving them bandwidth back. So they really appreciate the use of that technology.
Yeah, it's a Cube.js. I haven't used it personally, but it seems like a pretty unique piece of software, which brings up a final question. What do you have did you look at alternatives, or in fact, are there alternatives that would work with your stack that do what Cube.js does? And if so, what are they?
Yes, I think we did look at alternatives that time. I would say like 3 years back when we started to work with them. But none of them were as seamless as like Cube was showing. So when we picked up Cube, we actually didn't pick up Cube directly. We wanted to work with POC. I talked with Pavel. I know Pavel has a talk coming up in the day, but I mean like I talked to him like this is what we want to do, and so I think. What struck the deal in the sense like why we went to Cube was also because the way the community was projected. Like we worked on it together. We had discussions like, okay, this is our use cases. So yes, we did look at some things, but we did not follow up that because the way Cube actually like showcased us are in the POC plus their community, their communications. Pavel and Artyom, they like talk to us for different use cases. That pushed us towards using Cube.js more. And I think we are all very happy with where we are today.
Wonderful. We're at the top of the hour, so thank you so much for this talk. Tanvi and Stephen, really have a pleasure to have you here at the conference today. As Tanvi just pointed out, there is a follow-on talk by Pavel Tiunov that's at 3 p.m. Pacific. He'll be talking about design decisions behind CubeStore, so you can dig into this even further and understand the internals that made this application possible. Thanks again. Glad to have you here, and enjoy the rest of the conference. We're going to go ahead and close this call.
Thank you, guys. Have a nice day.